Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of congruence and transformations. This is standard 8.10b in the great state of Texas, and we are using item number 12 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have got a transformation. They don't even have it pictured for us, so we are going to draw some pictures to visualize it, but some type of transformation is applied to create a new figure. We're looking for the one that does not preserve congruence. So let's take a look at what these mean here. So F, rotation 270 degrees counterclockwise. All right, so let's just draw something. And let's make it super simple. All right, so I'm going to, let's just say it's a rectangle. Let's say we're gonna draw a rectangle. I'm gonna keep it in quadrant 1. All right, so counterclockwise is gonna go to the left, right? That's the opposite direction of the way a clock moves. And each of these coordinates is 90 degrees, right? So here's my 90, here's my 180. Here's my 270, because if I make it all the way back to the beginning, it's up to 360. So it's going to go all the way this way. So it's going to look kind of like this, I believe. If I visualize that correct. Maybe it needs to be a little bit skinnier. But it's going to be pointing in a slightly different direction because it's just kind of rotating around the origin. So pretend that's that same rectangle. But the question is does this preserve congruence? Well, I'm not doing anything to the shape. I'm just kind of turning it around the origin. So that is going to be the same size and the same shape. So that does preserve congruence. Let's check G here. Because we're not changing it. We're just making it change position. See if I can get that same rectangle in that same position in quadrant 1. And I want to reflect it across the y-axis. All right, so here's my y-axis right here. It's vertical. And I'm just going to kind of reflect it. I'm going to flip it over here. All right, so I just feel like you kind of flip it over like it's a deck of cards. You flip it from the front side to the back side. Once again, I'm not doing anything to change the shape. I am simply moving its position. So this is a turn in F. This is a flip. Technical terms being rotation and reflection. All right, so neither of those are changing the size of the shape. So it is preserving congruence. Let's check H. All right, so we're going to get that same rectangle right there. A dilation, by a scale factor. Well, here's your big clue right there. Factor. Factor is what we do when we multiply. So if I'm going to dilate something, I'm going to either grow it or shrink it. I'm going to enlarge it or shrink it. In this case, I'm going to enlarge it by 1.5, by 1.5. So I'm going to kind of take it and it's going to become a little bit larger. It's going to shift a little bit if I'm just taking my x's and my y's. It's going to turn into something like that, so I'm going to grow it. And obviously, if I'm growing it or shrinking it, I am not preserving congruence. I'm changing the size. So it is a similar shape. It's similar, but it's not the same size, which means I'm pretty sure that's going to be my answer. Let's check my J. J, we're going to get the same rectangle up here. And a translation. All right, so that is a slide. We're going to slide this down 50 units. So it just feel like you put your hand on it, you just slide it down. But we're not doing anything to change the size or the shape of the image or the shape. We're just sliding it down. We can slide it over, we can slide it diagonally, we can slide it any way we want to. But when we slide it, when we flip it, when we turn it, we are preserving congruence, staying the same. When we dilate it, we either grow it or shrink it, depending on the scale factor. We do not preserve congruence. Our answer is H.